Welcome back. This is the third lesson recording for IM1, March 2nd, 2021. Let's continue Katya's salary increase. What about 10 years later? If the pattern increases that each year she's getting additional 8%, she's getting 8% salary increase. Okay, so if Katya is getting 8% increase each year, what is her salary in 10 years? Well, to do that, it will be easier if we can figure out a generalized equation, not just be multiplying each time. So what we can do is, we know that in year 0 she got 100,000. In year 1 we multiplied that by 1.08. In the year 2 we multiplied that by 1.08 and another 1.08. So the previous by another 1.08, and then year 3 was whatever was previous, which was all of this, multiplied by another 1.08. So we keep on multiplying by 1.08 each time. So that means for the 10th type, we are going to be multiplying the initial value, $100,000, is going to be multiplied first, and then we're going to multiply 1.08 however many years we're talking about. So in this case, 10 years, it's going to be 1.08 to the power of 10. So with that, you are going to continue with card number 12 to 17 of Desmos. So we're looking at population growth. So it's a deer population. What do you notice? What do you wonder? So if I play this, okay, there's some, you see the years increasing. And what's going on in year 7? There are this many number of deer. Let's play that again. What about in year 1? It was much fewer, and it seems to be increasing and increasing as they reproduce. What do you notice? What do you wonder? The deer population in New York State is estimated to be 70,000. If the deer population increases by 9% each year, what will be the deer population next year? Briefly explain your work. Okay, so how would we calculate that? What we can do is we can multiply $70,000 by 9%. So that's going to be 0.09. That's the conversion of 9% to a decimal, multiplied by 7,000. Okay, 1% is going to be 70, because I can move the decimal place 2 places to the left, and then multiply 70 times 9 is going to be 630. So that I know that by the second year I have 630 more deer. So that's going to be 70,000 plus 630 is going to be 70,630 deer. Okay, Shasha's work is shown below. Total deer population is 70,000 multiplied 1.09. What did she do? Instead of multiplying 70,000 by 9, she multiplied to calculate the increase and then adding it to 70,000. What she did was very clever in that she added 1 to it, so it became 1.09. So with the increase, it's going to be 1 plus whatever the decimal portion of the percentage increase, so that's going to be 1.09. And if I do that, I get 76,300. Where did he get 1.09? He got the 1 from the fact that that's the amount that we need to add, and 9 is the part that is the increase. Oops, went too far. Okay, another year passes. What do we expect the deer population to be? Okay, so we started with 70,000. So we can put 70,000 and multiply that by 1.09. And this time I can multiply this 2 times. So I can actually square it and then multiply it. So when I do that using my calculator, that's going to be 1.09 times 1.09 multiplied by 70,000 is going to be equal to 83,167 deers. Okay, fill in the pattern that can be used to calculate the deer population for the years below. Okay, we can multiply 1.09 to the previous. Okay, so whatever is previous, I'm going to multiply another 1.09. So that's going to be 70,000 multiplied by 1.09. But this time I am going to multiply one more time. So we are already multiplying once here, so I'm going to multiply twice here. Okay, so then do you notice the pattern here? It's going to be 70,000 multiplied by 1.09, this time to the power of 3. 70,000 multiplied 1.09 to the power of 4. Do you see the pattern? Depending on the year, I'm going to raise that 1.09 to the power of 4. So that becomes 770,000 multiplied by 1.09. And the year has the variable of x. So this is going to be the equation to represent the population for any given year x. Okay, this time we're given an equation. The equation m is equal to 1,800 multiplied by 1.02 to the power of t. Models the number of members m of the gym t years after the gym opens. So what can you tell from this model? What can you tell from the equation? What is the initial amount? Okay, what do you think in year 0, what is the number of members that they started off with? Well, it's always going to be this number right here. Or you can think of it as, in the beginning, t is equal to 0, so m is going to be equal to 1,800 multiplied by 1.02 to the power of 0. But I know that 1.02, anything to the power of 0 is just 1, so that just comes to 1,800 members. Okay, or you could just get it from the equation that it's the number without the exponent is the initial value, what you're starting off with. And what else do we know? 1.02 represents the growth. Okay, what is the percentage increase? That's going to be 22% increase. Okay, so that's it for today. So you are going to enter in the table of content what we did today, which is exponential growth with percentage increase. Thank you for listening.